Hello everyone, I welcome all of you to yet another video. In this video, we are going to discuss operators in quantum mechanics. Now, what are operators? You must have studied arithmetic operators like addition, subtraction, multiplication, division. So, you can see we have this plus sign. So, whenever you see plus sign, you know what you have to do. You have to add the numbers. Then this cross, it's same sign of multiplication. So whenever you see this, whenever you have any number and this appears, you know what you have to do. You have to multiply the numbers. Similarly, for this symbol of division, you know what you have to do. And then we have this minus sign for subtraction. So all these are operators. They operate on numbers and we know their function. In the same manner, quantum mechanics has its own operators and we call it quantum operators or simply operators. We have not given any particular name because it is not necessary that the operator would be performing a particular function. ये बिल्कुल भी जरूरी नहीं है. That's why what we say is we only call them operators. और उस operator का task कुछ भी हो सकता है. It can be a differential operator, it can be arithmetic operator and so on. So that's why in general we call them operators. Now this quantum mechanics is a kind of mathematics. In all the derivations you would see that we are just solving everything mathematically. So this operator we denoted by x cap. You must be knowing what is cap. We have used this cap in our vectors. We denote unit vectors by indicating cap overhead, right? So यहाँ पर operator को हम इस तरह denote करते हैं, in general x cap. So when this operator operates on a given function f of x, means we have some function f which is depending on x. जब भी हम किसी वेरिएबल को parenthesis में लिखते हैं, that means वो particular function f is depending on that variable. जैसे ही x change होगा, our function would change. All right. So we have f of x as our function. So when this x cap acts on this function, it would give us some another function. So it will perform its function, it will perform its operation, and in result we would obtain some different function. Because अब fx पहले जैसा तो नहीं रहेगा, there would be some change and we will obtain, say, capital F of x. This is the mathematical way to represent it. If suppose our x cap is a differential operator, we know d by dx is our differential operator. So what is the function of this operator? It will differentiate the function on which it will act. So if this is our operator and our fx, our function is x square. Okay, so this clearly tells us that this function is depending on x. Now when this x cap would act on fx, what we would do exactly? Our x cap is differential operator here. So d by dx is acting on fx. And what is fx? That is x square. अब इसकी differentiation क्या होगी? 2x. So this is the final answer, and obviously this 2x is not similar to fx, right? हमारा जो fx था, that was x square. But now after operating this operator, we have obtained 2x, which is definitely not the same as our original function. So this is some other function and we denote it by capital F of x. Okay, so I hope you have understood the role of operators. In general, we denote them by x cap, और ये कोई भी role perform कर सकते हैं. Because quantum mechanics uses mathematics, so everywhere either we are differentiating or sometimes we are integrating, so it can be anything. So according to need, we apply specific function we attach specific functions with these operators, and when they act on our original function, we obtain some other function. तो जैसे हम प्लस माइनस मल्टीप्लिकेशन डिवीजन के बारे में पढ़ते हैं, वी नो कि जब ये नंबर्स पे ऑपरेट करते हैं so they give us some different result. Similarly, यहाँ पर जो operators हैं, they act on functions and they give us some different function. Now let's talk about properties of operators. Now all the operators in quantum mechanics, they are linear operators. Okay, linear operators. Now there is some meaning for this linear operator. Since this video is for undergraduate students, those who are studying BSc, they must be studying linear algebra in mathematics. So if they have studied that, they can actually understand this better. So if you have studied or you are studying linear algebra in mathematics, then you can actually understand it in a better way. But it is still easier. Now the operator is said to be linear if it satisfies these conditions. So first is that when operator acts on the sum of two functions. So this psi1 and psi2, these are wave functions. Always remember, in quantum mechanics, we talk of functions and they are wave functions. Quantum mechanics हर चीज को as wave consider करती है. So if it's a particle, even still it would say that it's a wave, and it associates wave with matter also. क्वांटम मैकेनिक्स ये कहती है कि इवन मैटर की भी वेव्स हैं. एवरीथिंग इज वेव लाइक. ये सबसे बड़ा पॉइंट है क्वांटम मैकेनिक्स का कि वो हर चीज को इन टर्म्स ऑफ वेव डिटरमिन करती है. Even if you talk of particle, even if you talk of electrons or protons or you have anything, they would still associate wave with it, because they say that everything is wave like. It's just that कि कहीं पर अगर वो stable है तो we can actually consider it to be a particle और हम उसकी position को clearly specify कर सकते हैं. Alright? So macroscopic level पर यानी कि bigger sizes पे हम उन्हें objects की तरह perceive करते हैं, but smaller atomic level and subatomic level पे we perceive them like microscopic particles, and those particles are more wave-like. They exhibit wave nature rather than the particle nature. So if you have two wave functions, so be it anything, we will associate wave function with them. And we always talk in terms of wave function whenever we are studying quantum mechanics. So if this operator x acts on the sum of these two wave functions, then that would be equal to operator x acting on psi1 individually plus operator x acting on psi2 individually. So this is very simple to understand. अगर हम numbers की term में बात करें तो if we have a number like 4 and suppose psi1 is exhibiting number like 2 and psi2 is exhibiting number like 3, so basically we have 4 multiplied by 5 which would give us 20. और अगर हम इस side पे देखें तो we are saying that 4 multiplied with 2 plus 4 multiplied with 3, that should also give us the same result, that is 20. So let's see, 4 2s are 8 plus 4 3s are 12, so again 20. So we can understand it simply in terms of numbers. But यहाँ पर numbers की जगह we have wave functions. Okay, so one thing is this. Next is, if operator is acting on any psi function which has been multiplied with some complex constant, then the answer would be that the constant would remain as such. So we can bring it outside and we can actually multiply these two things. Or I would not say multiply. In fact, we can directly operate that operator on the function and then we can multiply the constant with the answer. इसको भी हम numbers की term में understand कर सकते हैं. Suppose this x cap is suppose 2x. okay, और ये c constant है, तो we are considering it to be some number like say 4, और इस psi function को we are saying that this is 3y, all right. So 2x, then 4 3s are 12y, and that would give us 24xy, okay. So what they are saying is that if you have a constant, so constant usually participate नहीं करता, in the sense कि वो हमेशा ही same ही रहता है. So whether you keep it inside along with the wave function and then operate operator on it, or you just bring it outside and just operate the operator on the function, answer would be same, because c would never change. We are saying that c is a complex constant. So it is constant. So even if you operate any operator on it, it will not change. अगर हम x cap को c पर act करवाते हैं, c would not change because c is a constant. और constant का मतलब ही ये होता है कि that it will not change. Its value will not change. So in this case, suppose if we bring this 4 outside and we are directly acting this 2x on 3y, so we would get this 3 2s are 6xy and again 24xy. Okay, so you can actually understand this. Now let's talk about types of linear operators. So the two most common operators that we have are identity operator, which is denoted by I cap, and second one is null operator or zero operator, which is denoted by O cap. अब ये आपने words शायद सुने होंगे in matrices. You must have studied identity matrix. Even quantum mechanics actually deals with matrices. When you'll study in further topics, you will see that somewhere at maximum places we make use of matrices to understand the operators and the terms. ठीक है, so ये operation almost same ही है. Most of the time operators they perform the role of matrices. तो ये identity operator is almost like identity matrix, जो कि क्या होता था 1 0 0 0 1 0 0 0 1. So what was the role of this identity matrix? When you add this matrix to any other matrix, then things change. But if you multiply this matrix with any other matrix, things remain the same. So अगर हमारे पास A matrix है and we multiply it with identity matrix, we get A matrix back. So ये सिर्फ तभी जब multiplication हो रही है. And in operators also, what we do, we don't say that we are multiplying operator on wave function. We say that that operator is acting on the wave function. But ultimately, you can see that if we write anything as it is, अगर हम कोई भी दो symbols को इकट्ठे लिखते हैं, in general we say that multiplication is taking place. But यहाँ पर don't confuse that this is multiplication, because we know that this x cap can be anything. If x cap is differential operator, it will differentiate the function. So it can perform various roles. But just to understand identity operator, it's quite like identity matrix. Similarly, null operator or zero operator is quite like zero matrix. So if you have zero matrix and if you actually multiply any matrix with this zero, you would obtain zero. Or you also can say that this is more like zero vector. If you multiply any zero vector with any other vector, the result is zero vector. Okay, so this is the way to understand these two operators. Here you can see identity operator is that operator which, when operated on a function, leaves the function unchanged. That means the function remains as it is. So that's why we have this I cap acting on psi and we get psi back. And null operator is that which, when operated on function, makes the function zero. So here you can see when this zero operator acts on psi, we obtain zero. So both these operators are linear operators and very simple to understand. Let's talk about algebra of linear operator. किस तरह के calculations are possible. Now let A and B, or A cap and B cap, are two linear operators. So the sum of these two operators would be C cap, that is equal to A cap plus B cap. Obviously, their sum would be some different operator. If you have one number as 5 and another number as 3, so their sum would be 8. So again, a different number. Now, the sum of two linear operators should also be linear. So here we are saying that the sum is also linear if following condition is satisfied. So the condition is same. The condition that we mentioned here in properties of operator, that for any operator to be linear, these two conditions should be satisfied. तो अब अगर ऑपरेटर्स का आप सम कर रहे हो तो वो भी एक ऑपरेटर होगा, and for that operator to be linear, again these conditions should be satisfied, and that's why ये जो condition है, this condition we have picked. अब यहाँ पर a cap plus b cap था, which gave us c cap. That's why we have written that c cap operating on psi should be equal to a cap plus b cap and their sum operating on psi, or we can say that a cap operating on psi individually plus b cap operating on psi individually. Easy to understand, and you can also understand it in terms of numbers. Okay, so now the next is sum of two linear operator is commutative. You know commutative law. In vectors we have already studied that a vector plus b vector is equal to b vector plus a vector. In fact, dot product is commutative. That means a vector dot b vector is equal to b vector dot a vector. Similarly, if you have two operators, sum of those two is again commutative. So a cap plus b cap is equal to b cap plus a cap. So it's like 5 plus 3 is equal to 3 plus 5. Third point is that the operator do not necessarily commute. अब इस चीज को हम नंबर्स की टर्म में नहीं समझ सकते because numbers always commute. So they are saying that it might be possible that they would be commuting, and it is also possible that they might not be commuting. So A cap and B cap, they are operators. Actually, they are not numbers. We are just understanding them in terms of number because it is always easy. But actually, A cap and B cap, they are just operators and they can be of any type. So it is possible that they might commute, and it is also possible that they might not commute. So अगर ये term है, so how can we write it? This means A cap B cap minus B cap A cap of psi is not equal to 0. If we bring this B cap A cap psi to the left hand side, so we would get 0 on the right hand side, and we have this not equal to sign. Okay, so this is as it is. Now where this term that we have written, this A cap B cap minus B cap A cap, there is a way to represent it, and it is represented as A cap comma B cap within square brackets, and it is known as commutator of operators. So this A cap B cap minus B cap A cap, this is represented by A cap comma B cap within square brackets, and it is known as commutator of operators A and B. And we also represent it as A cap comma B cap within square bracket not equal to 0. That means here operators A cap and B cap are not commuting. When they actually commute, in that case A cap comma B cap within square bracket is always 0. So always remember, this is a way to represent. If two operators are commuting, then we write them within this square bracket equal to 0. And if they are not commuting, then we write them within the square brackets and not equal to 0. Okay, so this is all about operators. We have talked about operator in general, then their types, properties, and algebra. That's all for today. Thank you.